17th. We are pushing our test, excuse me, we are pushing the test for Unit 2 that was supposed to be today because of the laptop distribution, and not everybody's is updated and not everybody has the lockdown browser downloaded and working. Okay, so I'm going to go and show you, let's look at the calendar. So this is not updated yet. We're just going to talk about it real quick. Okay, so what was supposed to happen this week was the test was supposed to be today, and then Algebra 2 team has a planning day tomorrow. All the Algebra 2 teachers will be on campus, but not in the classroom. There will be a sub in the classroom. So because of that, we can't test tomorrow either. Okay, so we're pushing the test. We can't test tomorrow though. And then Thursday, we're on pep rally schedule. So I haven't seen the bell schedule, but I'm pretty sure they shorten our class periods. So we're not going to test if the class periods are shortened. So it's looking like Friday is going to be when the test is pushed to. That does not mean we're not going to do anything till Friday. We can't just push everything. So everything else is just kind of moving up and being shifted. So we are going to cut this. We were going to do a little mini lesson on using technology for systems on the day we were out. But we're going to cut that. So I'll kind of update this as I'm going through it with you. All right, so we are not going to do that. We are going to go ahead and talk about key features notes. So I'm going to cut that and move it to today. And we're actually not going to get to the Delta math, so there's not going to be a practice today. So functions and key features notes. And then tomorrow, there were going to be a video lesson. Since we won't be in here, we'll create the lesson as a video, which means you need to bring headphones or something to listen to the video. If you don't bring anything and you want to listen to it outside of class, that's fine. I'll probably get it posted this afternoon. So you could even listen to it tonight from the comfort of your home and not have to use headphones. Just watch the video, and then actually you wouldn't be able to take the notes because you don't have the notes sheet. So that, I guess you could watch it without taking notes, but that's probably not the best. So you can watch it during class tomorrow or during Cat Tracks tomorrow or after school tomorrow, but there will be a video posted here. I'll put the link. And it's going to be this lesson of transformations of the absolute value function. That here. And there will be some Delta math practice. And then our test is going to get pushed to Friday. And so that means the review also is always due on the day of the test. So you're getting you're getting a whole week now to do your review. Okay, so the review needs to be done by Friday. And then that's going to push these notes. Should go up a day to Thursday. Okay, so that kind of updates this week. Okay, so I'm going to put a note here. Unit 2 test pushed to Friday. So we're doing some key feature notes today. Okay, and no assignment today. And then tomorrow in class, you'll have a video to watch. I'll put here that it's a video. And I'll link that once the video is posted. I'll make that word video a link directly to the video. So you'll just be able to go there and click it. Okay, I think that's it for this week. I'll update the rest of the calendar later. That's good enough for now. It's got this week updated. Save that. Okay, and again, what else besides the review due date getting pushed? It also means these Delta Math assignments are extended. Not the original due date is not extended, but the late credit available deadline is extended. So the only one that's still available for full credit is the one from Friday, the mixed practice. It is due tonight by 11:59 p.m. and then it'll drop to 75% credit for 2 days and then drop to 50% credit after that. Okay. But everything else, these 5 assignments from before, okay, these are still available for late credit. So you can see 3 of them are at 50% credits right now. 2 of them are still at 75% credit, but one of those ends at 11:59 tonight and the other one at 11:59 tomorrow. So pay attention to those. Those will drop to 50% credit then. And then everything, you can see the 50% credit until September 22nd. Because remember, I've always told y'all if something is going to land on a Friday, a due date, which they would now because the test is Friday, then I'll give you the weekend. So you have till Sunday night at midnight to get any of that late work done. Now, again, I would do these that are at 75% credit or the one that's at full credit first while you can get the most credit. But then the stuff that's already dropped to 50, I would do the other stuff first and then come back and you have till Sunday night to complete anything else. Any questions about that? So you only are going to lose late points on the answers that you answer late. So Delta Math audit, it timestamps everything. So what you did on time, you'll get full credit for. And if you go back and complete more, then the grade will update. And you only lose the late points on the part you're answering late. So if I put the grade in already and you had only done like 50 or 80%, and that's the grade I put in, when I go to update late grades, I'll look and see if it's changed and I'll update it in Skyward. So yeah, you can still go back and do things even if it's already in Skyward. If you go back and complete more, I'll see that. You don't need to email me or anything when I go to do late grades. I'll get that updated. Okay, so the next thing we need to do to make sure we are ready for when that test is pushed is go to the software center. So I asked y'all to get your laptops out. So you're going to go to your software center. Okay. And let me clear out. So on this screen, when you come to your software center, this is what it'll look like. And what you're going to do in this search bar, I need you to type in lock. Okay, you can type lockdown, but lock is fine. You can just type lock, and we're looking for that Aware lockdown browser. Thank you. Okay, so there's 3 lockdown browsers that pop up here. One says for Elevate, one says for Aware, and one says for Canvas. We're looking for the one for Aware. Okay, we do not use the one in Canvas, or we have not yet. Maybe we will in the future. Some of your other classes might. So if you want to go ahead and download or install the one for Canvas as well, that's fine. But the one that we absolutely must have for Algebra 2, all of our tests will be in Lockdown Browser. It will be this one. So when you click on it, you should see the install button and you just click install. Now, one of the reasons the test was pushed was some people's laptop distributions were later in the day or they're not getting them until today. And so that update process on the new laptop is taking a really long time. Now, yesterday, some people got it to where it was updated and they were good to go. But when we went here to download this lockdown browser, they got a notice down here where it says status. It said failed. And they had a retry button up here. And we kept retrying and it was not working. Okay. This is what it should look like. When you clicked on install, it should take a minute, maybe a few seconds, however long. But then the status should say installed. Okay. And this is what your screen should look like. If this is not what's happening, we need to get it taken care of. If you get a failed status here, okay, we need to go and get you your laptop looked at by technology help so that you'll be able to take the test when it's time. Okay, so if you get a failed status, you need to let me know so I can send you down for help from tech. Is everybody in here good? Did everybody do this process? Everybody should be doing this process on their new laptops. I asked you to get your laptops out, go through this process.
What said failed?
It says failed? Okay, bring it over here. Did anybody not get their laptop yesterday? You're going to be keeping that one?
Yeah.
Okay. And you have it installed already? You're good? Okay.
I just installed it because I had the Texas Secure one, but I didn't have this.
Okay. All right. So everybody should be good. Did you want to bring it over here, Rylan? Okay. Okay, perfect. All right. Then we should be good. If you are watching this on a video, go through that process and get that lockdown browser installed. Okay. So now we're going to get started on our shift and lesson and take our notes. Right there on the bookshelf. Okay, so we are looking today. Ben? I know the date is wrong on these because our whole thing is shifted around, so ignore the date. It's okay. If you want to mark that out and put the 17th, put 9/17 for the notes. So you know when we took them, you can. Okay, but this is what we're looking at today. Let me get this passed out. Yeah, once you have that installed, you do not need the laptop anymore for today. We're not going to get to an assignment or anything. We're just going to, since we took some time going over the calendar and installing. Not gonna have time to practice. I'm just going to mix this practice tomorrow's practice. Down in research. SOFT. You get yours? The lockdown room. Come down here to serve. Stop. SOFT. Yeah, aware. You're good. It's already installed, so you're good. Yeah, with software summit. These are the notes we're about to take right now. Right now. Yes.
We don't need it.
Here, third, lost.
It's a child.
Just like that. Did everybody get one? Guys, don't put those phones away for me. Okay, phones away, headphones, earbuds out. Okay, we're gonna try and get through as much of these key attributes as we can. We're not actually starting Unit 3 today, which is a focus on absolute value function. This is more of just a generic review of key attributes of all functions. Okay, it's really a vocab review. Okay, we need to know these terms so that when we're asked about them for any function, we should be able to answer. So we are eventually going to need to identify these in absolute value functions for Unit 3, but this is kind of just like a recap vocab review. Okay, so all of the graphics that you see, these are not necessarily, there will be some absolute value function, but you can obviously see these are not. Okay, so we're talking about each parent function has its own set of key characteristics, key features, key attributes. Those all kind of mean the same thing. Okay, but you have to know how to identify those and what those terms mean. So it's things like domain and range, vertex, intercepts, symmetries, asymptotic behavior, maximums and minimums, continuity, increasing and decreasing intervals, and end behaviors. Okay, so we're going to try and get through as many of those terms as we can today. What we don't get through, we'll finish another day. Okay. So we're going to start with domain and range. Okay, so we actually had a little mini domain and range refresher lesson. I guess it was back in unit 1. Okay, so remember we talked about writing domain and range in both inequality and interval notation. So domain, we need to remember that domain is our x's and range is our y's. Okay, and when we write our domain and range, whether we're using interval or inequality, we write our domain and range from least to greatest. Okay, so least, comma, greatest. Okay, when we're in interval, we'll use a parenthesis or a bracket. When you're trying to decide if it's a parenthesis or a bracket on the value, remember that if it is an infinity, positive or negative, or if it is an open circle, it's going to get a parenthesis because you cannot equal those. Parenthesis means not included. But if it is a closed circle, okay, it's going to get a bracket. Okay, a bracket means the value is included. Okay, so in terms of inequality symbols, a bracket is equivalent to when you have the or equal symbol. Okay, the parenthesis is equivalent to when you don't have the or equal symbol on your inequality. Okay, so brackets mean it's included, parentheses mean it's not included. Okay, so a little refresher there. So let's see if we can go over here and write our domain and our range for both of these graphs that we're given. All right, so I guess instead of putting the X and Y off to the side over here, I could just write it in here. All X values. So in this first graph, how far left to right does the graph go? What is the leftmost value of this first graph? Yeah, it's this point right here, which is at 1. Okay, and the rightmost that this graph goes is to this point up here, which is at 4. So our domain is here. Okay, it's from 1 to 4, which if I'm writing an interval notation, it's just going to be 1, 4, because it's least, greatest. Now I need to decide if I should have a parenthesis or a bracket on the 1 and the 4. So remember, an open circle, we said, indicates what? Parenthesis or bracket? A parenthesis. If it is an open circle, it is not included. So that one should be a parenthesis. And then we said that the closed circle indicates what? A bracket. That value is included. So we should have a bracket on the 4. So you don't have to have matching both parentheses or both brackets. You can have one and another. Okay, they can be mismatched depending on the graph. Okay, now in inequality notation, remember X is in the middle. We're talking about what X is between least to greatest. So X is in the middle, and our least value is 1. Our greatest value is 4. So this is read as 1 is less than X is less than 4. Now, should one of these have an or equal on the inequality? Which one? Yeah, the 4. Remember, if it's a solid point, okay, we want the or equal on there. So that one, it really should be x is less than, or excuse me, 1 is less than x is less than or equal to 4. So that's how that inequality notation should be written for the domain. Now for the range is all of the y values. And again, we still go least to greatest. So for y values, that's bottom to top. So what is the lowest this graph goes? Okay, and the highest appears +2. So this is our range in between those values here. Now, sometimes some people are, well, what about that open circle there? There's going to be a gap there at -1. Okay, but if you look across -1 all the way across, look over here, the curve crosses there, doesn't it? Okay, so even though it was an open circle here when y was -1, it exists here when y is -1. So there's not a gap in this range. Okay, it exists everywhere from -2 to +2. So in interval notation, I would say -2, +2. Okay, now we said a solid point up there meant included. So the +2 for sure has a bracket. The -2, there's not a point drawn. It's just the curve going through there. So what does that mean? It means it's included. It touches there. Okay, even though they don't have a point drawn, the curve or the line, whatever the graph is, it goes through that value. So that is also a bracket. So when I go to write this in inequality notation, this time, oh, get out of here. This time it's y in the middle. Okay, and it's from -2 to +2, but both of them were brackets in interval notation, so they should both have or equals in inequality notation. So far, so good? That's kind of our domain range refresher. Okay, now let's look at this one on the right. This is a piecewise function. It's multiple pieces. Okay, and we've got open circles on 2 of those points, but then the other 2 points are infinity because of the arrows. Okay, this arrow tells me this goes right forever. This arrow tells me this goes left forever. So what are those values when we say left forever or right forever? Well, it's infinity. Is what positive infinity is to the right and negative infinity is to the left. Okay, now looking in the middle though, there's a gap, isn't there? Okay, so that gap is from -2 to +1. Okay, so the function exists everywhere left of -2 and everywhere right of +1, but there's a gap in there. So to notate that that gap is there in interval notation, it looks like this. We would say least to greatest, so it comes from -infinity, and then it comes to -2, and there's a gap. Now that is an open circle at -2, so it's a parenthesis. And then to indicate that it picks up again, remember we use that union symbol. And then it picks up again at 1, also an open circle, so a parenthesis. And it goes to infinity. Now on my -infinity and infinity, do I use parentheses or brackets? Brackets. Remember up here we said open circle or infinity is parentheses. Okay, parentheses because you do not reach infinity. You cannot equal infinity. You never get there. So it's parentheses for infinity. Okay, so I'll highlight that as well in yellow because it's infinity, parentheses. Now in inequality notation, There's a break. So it looks like this. The left side is x is everything less than -2. So I'm just going to write x is less than -2. And the right side, everything to the right of 1 means x is greater than 1. And neither one of those inequalities should have an or equal, because it's not equal at either of those. They're both open circles. Now the range here, how low does this graph go? What's the lowest this graph will go? Now, looks like the lowest point shown is here, the open circle at 1. But yeah, Preston just said it. It's going to be -infinity because of the arrow. That same arrow that's going to the right is also going down. So this is going down and to the right forever. So it is going to go down. It doesn't show it lower than this point, but the arrow indicates that it will go lower than that point. So this is also going to be -infinity for the low. And then what about the high point? What's the highest this graph goes or will go? Well, same thing though. It looks like 7, but what does this arrow tell us? Yeah, it's going to keep going up forever. As it's going left forever, it's going up forever. So it's going to go up past that point that we see. So it's not from 1 to 7. It is from -infinity to +infinity. Now, there was a gap in the domain because we can see a break. There's nowhere that this graph exists at these x values between -2 and 1. But there's no break in the range. Even though this is discontinuous, meaning it's broken in pieces. Okay, if you think about the range, it's going down forever, it's going up forever. There is no y value where this graph will not exist. Okay, down here, this is going to be extended. You have to imagine it going down forever. And then when I get up here in this like broken section where it's in 2 pieces, it exists to the left and the right. It exists in multiple places. Okay, so there's no y value where the function doesn't exist. So the range is -infinity is less than y is less than infinity. Or we can use that symbol, somebody said it earlier, all real numbers. Okay, in interval notation, we would say -infinity, infinity. And we said infinity, positive or negative, doesn't matter, both get parentheses, not brackets. All right. Y'all feel okay about our domain and range refresher? All right, let's start. We won't spend as much time. That took a little bit longer than some of these other vocab terms are going to. Okay, so we want to get through as many as we can. A vertex. A vertex, or vertices, plural, okay, is it. And here we'll write down a definition. It's the a high. I should say the high or low point of a graph where the behavior changes. Now, when I say the behavior of the graph is like the direction of the graph. And when we read a graph, how do we read a graph? What direction do we read a graph? Left to right. Okay, so I'm going to make a note of this. When I talk about the behavior changing, we are reading left to right, just like we read a book. Okay, so if I'm looking at this first graph, this parabola, if I start to trace this, okay, from left to right, what direction am I going? Am I decreasing or increasing? I'm decreasing. This is going down. This is going down. Until here. What happens here? It turns. Now what's the graph doing? Now it's increasing. Okay, so that's what I mean when I say change behavior. It changes from decreasing to increasing, or in this one, it changes from increasing. We get to this point here, it turns to decreasing. Okay, so that is a change in behavior of the graph. Okay, so when that happens, it creates a vertex. That is supposed to be highlighting, not circling. Let's try that again. So this point where it changed directions, okay, or where it changed behaviors, that is your vertex. All right, so what is the coordinate for this first one? What is that vertex? Where is it located? Yeah, and this is a point. How do we write points? As x comma y in parentheses, right? So x, y in parentheses, the y value is at -4, but the x value is at 1. So this is at the point 1, -4. Where's the vertex in this other picture? 4, 1. Okay, from the origin we go over 4, up 1. Oh, God. Yeah, hang on, my pen is being funky. I'm saving and I'm going to close and reopen this. See if I can get my pen to work again. Of course, still not working. Okay. Let me go up. So somebody asked to get domain and range real fast. Let me see if I can mess with the battery on my pen here. Get it to work. Is that good, right? All right, yay, pen working again. So that vertex was at 4, 1. So we've got our vertices highlighted and we write them as points, coordinate points. Feel okay about a vertex? Now a vertex, it can be a high point, it can be a low point. Okay, we're actually going to talk more about what those high points and low points are called. Definitely would have put these in a different order, but that's okay. We'll come back and talk about what those high points and low points are called in a little bit. All right, intercepts. Okay, intercepts are points also, okay, where the graph crosses an axis. Okay, so an x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. So on my graphs over here, we'll take notice the x-intercepts of this first graph. How many x-intercepts do you see on this first graph? Let's see, here's 1. I'm just going to go along the x-axis. There's a line crossing it. Here's the curve crossing it. And here's the curve crossing it. So that one actually has 3 x-intercepts. That's all right. So we have 3 x-intercepts. How many y-intercepts do you see? Only see 1. Okay, and you will only see 1 if it's a function. Okay, a function can only have 1 y-intercept. It can have multiple x-intercepts. A little memory trick I heard for this before, to help you remember that there can be multiple x's but only 1 y, is you can have multiple x's, like an ex-boyfriend or an ex-girlfriend. So you'll have multiple x's but only 1 wife. So only 1 y, but multiple x's. If that helps you remember which one you can have multiple of, but you can only have 1 of the other. If there's more than 1 y-intercept, it is not a function. Okay. All right, so I'm going to list those coordinates. So those x-intercepts, it looks like it's at -3, 0, 0.50, and at 4, 0. Notice the format of all of those is an x value and then 0, because your x-intercept happens when y is 0. You haven't gone up or down any. Y is 0. Your y-intercept happens when x is 0. So it's going to be in this format. So this one is at 0, -1. All right, so we'll pick up there tomorrow. I'll probably post the rest of this as a video for tomorrow.